Think felling a tree and slicing it into boards is all it takes? The reality is far more impressive. Behind every single plank of wood lies an entire chain of modern technology. From a lonely Ponce harvester deep in the forest and massive barges hauling thousands of tons of timber, to high-tech mills where X-rays and electromagnetic waves analyze and optimize every single grain. Join RaWMachines as we follow a log on this incredible journey of transformation. "3:30 a.m. In the dead of a North American winter, the temperature has plunged below -10 degrees Celsius. While most of the forest is still shrouded in darkness, the first shift has already begun. From a distance, the deep rumble of a diesel engine breaks the silence. A Ponce harvester slowly creeps into the logging area. With just a single operator inside its climate-controlled cabin, this machine can carry out almost the entire tree felling process on its own. The hydraulic arm reaches out. The harvesting head grips the trunk tightly. A high-speed saw blade slices through the base in a matter of seconds. As the tree begins to fall, the control system calculates the precise direction of the drop to avoid damaging the surrounding timber. But felling the tree is only the first step. The trunk is immediately pulled through a set of delimbing knives, where automated sensors measure its length before bucking it into exact mill standard logs. Once the first logs are neatly stacked on the snow-covered ground, the job is handed over to the John Deere forwarder. It doesn't fell trees. It doesn't cut logs. Its sole purpose is to transport every piece of timber out of the forest. Ahead lies nothing but deep snow, hidden rocks, exposed roots, icy terrain, and steep slopes with constantly changing elevations. Carrying dozens of tons of timber, the forwarder slowly works its way across each obstacle. Its drivetrain continuously distributes traction to each wheel, while the articulated center joint allows the entire machine to flex with the rugged terrain without compromising the stability of its load. After trip, the entire timber harvest is finally hauled out of the forest. the log yard, specialized log loaders begin lifting bundle after bundle of timber onto the barge. In many coastal regions of North America, this is the most efficient way to transport logs. Instead of sending hundreds of logging trucks along narrow, rugged forest roads, a single barge can carry thousands of cubic meters of timber in one voyage. Once loading is complete, the barge slowly departs the dock, gliding through narrow inlets, dense conifer forests, and snow-covered mountain ranges. The calm waters provide a far more stable way to transport thousands of tons of timber than road transport, while also significantly reducing fuel costs. After hours of travel, the barge arrives at Vaagen Brothers lumber. Once again, massive log loaders spring into action, carefully lifting each bundle of logs onto the mill's log yard. From this point on, the trees that only recently stood deep in the forest enter an entirely different world. While nature takes decades to grow a tree, modern technology is about to transform it into high-value wood products used around the world in just a matter of hours. At Vaagen Brothers, the goal isn't simply to cut more lumber. What's even more important is extracting the maximum value from every log while minimizing waste. As soon as a logging truck enters the receiving area, massive gantry cranes go to work. With a single lift, they hoist an entire bundle of logs, weighing dozens of tons, from the trailer and gently place it in the log yard. The entire operation is fast and precisely coordinated. Truck after truck arrives and departs in a continuous flow, ensuring the mill's production line is supplied with a steady stream of raw material without interruption. Next, the merchandiser scans the trunk to analyze its shape, curvature, and defects. The data is sent to an onboard computer, where algorithms instantly calculate the optimal cutting pattern, determining the precise length and quantity of each log. Instead of taking hours of manual measurement, the entire process now happens in a split second, maximizing both yield and wood value. Next, the logs are fed into the debarker. Inside, massive rotating drums continuously tumble the logs against one another, stripping away the outer bark while removing dirt, rocks, and other surface contaminants. The bark doesn't go to waste. It is collected and used as biomass fuel, providing heat and energy for the entire mill. Once the logs are debarked and cleaned, they move into the primary sawing area. Here, a hew saw cuts the round logs into square cants. Ultra-thin saw blades spin at blistering speeds, turning into nothing more than a silver blur to the naked eye. Inside the control room, the operator monitors every step of the process on display screens. Even though computers handle almost the entire operation, they keep a close eye on every single log to ensure everything runs smoothly, accurately, and safely. After sawing, the lumber is neatly stacked and moved into industrial kilns. Here, computers precisely control the temperature, humidity, and airflow to create the ideal drying conditions for each wood species. Hot air continuously circulates between the layers of boards, allowing moisture to evaporate gradually without compromising the wood's structural integrity. Over the course of 3 to 5 days, a network of sensors constantly monitors the condition of the wood, automatically making adjustments whenever necessary. As a result, the lumber is far less prone to cracking, warping, or shrinking, achieving much higher dimensional stability. While traditional air drying used to take months and depended entirely on the weather, modern kiln drying technology produces uniformly high-quality lumber, with precise moisture content in just a few days. Once the lumber reaches the ideal moisture level, the boards are transferred to the planer mill. High-speed cutter heads spinning at over 10,000 revolutions per minute smooth all 4 sides simultaneously, bringing each board down to its exact finished dimensions. At the end of the line, workers hand inspect every single board, examining the surface and feeling the finish to catch even the slightest imperfections. Only after passing this final inspection is the product ready to leave the mill. Finally, the finished lumber is stacked into bundles, tightly secured with steel straps, and wrapped in protective coverings to prevent damage during transportation. From there, the bundles are loaded onto rail cars and trucks, leaving the mill to travel across the United States before continuing their journey to construction sites and homes around the world. From high above, the Vaagen Brothers line operates like a finely tuned machine, where every single component moves in seamless, precise harmony. Yet, The most valuable part isn't the state-of-the-art equipment, it's the partnership between human ingenuity and technology. Because technology was never built to replace us. It was created to help us achieve what we once thought impossible. Leaving Vaagen Brothers lumber behind, our journey continues to Magnolia, one of Weyerhaeuser's flagship sawmills. This is more than just a lumber mill. It's a fortress of technology, where generations of woodworking expertise meet some of the most advanced manufacturing systems in the industry. Every day, the mill processes approximately 200,000 board feet of lumber, enough material to build around 40 new homes. With this level of scale and precision, the productivity of its modern production line far surpasses what traditional sawmilling methods could ever achieve. Each log's journey at Magnolia begins in the mill's vast log yard. Every day, a steady stream of trucks delivers southern pine logs measuring more than 40 feet long and approximately 24 inches in diameter. Despite their massive size, the logs are quickly unloaded using specialized equipment and placed in the yard, ready to enter the production line. From the log yard, logs enter the primary sawing system one by one, the stage that determines most of the recoverable value from each tree. The heart of this area is the twin band head rig, which utilizes two bandsaw blades roughly 12 feet long, operating at extremely high speeds. However, before the blades even touch the wood, the scanning system has already completed its job. Computers analyze the entire geometry of each log, from its diameter and taper to its sweep, and calculate the optimal rotation angle and cutting position. The goal is to maximize the yield of high-value lumber while keeping waste to an absolute minimum. Few people know that modern bandsawing technology actually traces its roots back to an idea proposed in 1808. At the time, however, metallurgy was not yet advanced enough to produce blades durable enough to withstand high tension and rapid operating speeds. Only after decades of improvements in steel quality did the bandsaw truly reach its full potential, gradually becoming the backbone of the wood processing industry. More than 2 centuries later, that fundamental principle remains unchanged, but the way it operates has transformed completely. At Magnolia, traditional saw blades are now paired with modern sensors and optimization algorithms. No two logs are processed in exactly the same way. Every single cut is individually calculated based on the log's unique natural profile, ensuring maximum value extraction before it moves on to the next stages. After the twin bandsaw converts the logs into square cants, they are sent to the gang saw. Instead of relying on a single blade, a gang saw uses an entire array of parallel saw blades, allowing multiple cuts to be made simultaneously as the wood passes through just once. This dramatically boosts productivity, processing up to 10 times faster than a single blade operation. Before each cut, a network of lasers and sensors scans the dimensions of every cant. The computer then automatically adjusts the blade alignment and feeds speed to optimize each cut, increasing productivity, minimizing waste, and extracting the maximum value from every piece of wood. After leaving the gang saw, the boards have reached their basic dimensions, but their edges remain rough and uneven. To meet finished product standards, they must go through the final processing stage, edging. In this step, the machine removes excess wood to create straight, parallel edges. Operating at speeds exceeding 1,000 feet per minute, a margin of error as small as a fraction of a millimeter can cause an entire board to be rejected. Because of this, the entire process is guided by an optical sensor system, ensuring the blades cut with exact precision along the calculated path. No two boards are exactly alike, and this is where modern technology truly comes into its own. An optical grading system scans every board, analyzing the grain pattern, knots, and internal structure to determine its highest value use. Whether it's structural lumber for home framing or premium boards destined for fine furniture, each piece is sorted with exceptional accuracy. More importantly, at Magnolia, virtually nothing goes to waste. Every part of the tree is put to use in one way or another. Large wood chips are sent to paper mills where they are turned into printing paper, cardboard, and a wide range of recycled paper products. Fine sawdust is compressed into biomass pellets, providing a renewable fuel source for heating and power generation. Tree bark is processed into landscaping mulch for parks, gardens, and even children's playgrounds. It reflects a philosophy often summed up in the saying, "Waste nothing, want nothing." When nothing is wasted, nothing is in short supply. Magnolia operates as a closed-loop ecosystem. Trees grow from the land, pass through the production process, and return to serve society in many different forms. This approach has enabled the mill to achieve an extraordinary wood utilization rate, recovering nearly 100% of every tree, a level of efficiency once considered nearly impossible in the lumber industry. Next comes a stage that directly impacts the final quality of the boards: kiln drying. Between each layer of lumber, thin wooden spacers, known as stickers, are inserted to create gaps, allowing air to circulate evenly throughout the stack. The entire stack is then loaded into an industrial kiln, where the moisture content is controlled and reduced down to approximately 10 to 15%. It is this process that stabilizes the wood structure, minimizes warping, and prepares it for its journey to becoming finished products. Upon exiting the dry kiln, the boards enter the planer mill. High-speed rotating cutter heads machine all four sides simultaneously, shaving off any remaining minor imperfections and bringing every product to its exact target dimensions. From raw logs freshly harvested from the forest, the lumber has now taken its final shape, ready to serve the construction and manufacturing industries. At the final stage of the line, automated robots neatly stack the boards into units before a strapping system secures each bundle. At the same time, each unit is tagged with an identification code containing full tracking details, such as batch code, production date, grade, and destination. All data is saved in a central management system, making origin traceability fast and accurate. Once completed, forklifts transport the packaged lumber to the shipping yard for loading onto trucks or train cars. Its journey inside the sawmill has come to an end, but the journey of the lumber is just beginning. They will travel on to construction sites, manufacturing plants, and homes around the world, carrying with them the mark of nature, human craftsmanship, and technology that together brought them to life. Leaving the American South behind, our journey continues northwest into the region's famous Douglas fir forests. Amidst this backdrop, the U.S. timber industry pioneered an entirely new path: engineered wood products. While Magnolia showcases the strength of traditional lumber milling, Boise Cascade tells a story of transformation. Here, wood is no longer simply sawn from a tree trunk. It is redesigned, reconfigured, and reinforced to become a modern, advanced material. The concept of the wood I-joist emerged after World War II, as America entered a post-war building boom. Millions of homes needed to be built at a time when large timber resources were becoming increasingly scarce. Engineers were forced to find a solution that was both material efficient and strong enough to replace traditional solid lumber. The answer came from a design long familiar to the construction industry, the structural steel I-beam. They realized that most of the load is concentrated along the top and bottom flanges, while the middle web primarily serves to connect them and transfer force. Based on that exact principle, the wood I-joist was born. Now, let's get to the best part, the I-joist manufacturing process 1, drying. The process starts with thin veneers peeled from tree trunks. These veneers pass through a continuous drying system, where hot air flows at around 200 degrees Celsius directly through each wood layer. In just a few minutes, the moisture content drops to approximately 6%. This creates the ideal condition for the adhesive to penetrate and form a strong bond in the subsequent steps. If the veneer is too moist, the glue joint will be weak. Conversely, if it's too dry, the wood can become brittle and lose quality. Two, flange fabrication. Leaving the dryer, the veneers move to the LVL production line to create the top and bottom flanges of the I-beam, the components that carry almost the entire structural load once the building is in use. Each veneer sheet is coated with phenol formaldehyde resin, which offers excellent water and heat resistance. They are then stacked in dozens of layers to form a thick billet. Once the target thickness is reached, the entire assembly enters a hot press operating at around 170 degrees Celsius. Under immense heat and pressure, the resin melts, deeply penetrating the wood fibers before curing. This transforms dozens of individual veneer layers into a dense, solid LVL billet with strength superior to natural lumber. After cooling, the LVL billets pass through high-speed routers to mill continuous precision grooves along their edges. 3. Web fabrication. Meanwhile, on an adjacent line, the web portion of the joist is being produced. Thousands of long wood strands are oriented in engineered directions, blended with adhesive, and pressed into OSB panels. This intentional orientation gives the OSB exceptional shear strength while keeping the joist lightweight and dimensionally stable over long spans. 4. Assembly. With both components completed, they come together at the assembly station. The two LVL flanges are positioned parallel to each other, and the OSB web is precisely fitted into the pre-routed grooves. The entire joist assembly then passes through a radio frequency bonding system, which uses electromagnetic waves to instantly cure the glue joint. 5. Final cutting and inspection. After bonding, the joists emerge and are cut to standard specified lengths, commonly 8, 12, or 16 meters. Each joist then undergoes automated ultrasonic testing to detect any hidden defects within the glue lines or veneer layers. Once fully compliant with quality standards, the products are inkjet coated with a moisture barrier, and strapped onto pallets for shipment to job sites across North America. Every I-joist is the result of multiple engineering disciplines working together. More than that, it reflects how people reimagine natural materials to create products that are lighter, stronger, and more efficient. At Boise Cascade, there's a saying, "Wood is already good. Our job is to make it smarter." That philosophy defines the entire mill, not simply harvesting nature, but applying engineering to unlock its full potential. Leaving the United States behind, the journey of wood carries us across the Atlantic to southern Germany, home to Möhringer and Lagenbau. In the aftermath of World War II, with their nation in ruins, the German people chose to rebuild through quality. They could not compete by producing at lower costs, but they could distinguish themselves by producing better. One, laser scanning. At Möhringer, every log undergoes a thorough health check before being processed. A multi-tier laser system continuously scans the entire surface as logs move along the conveyor, creating a high-detail, three-dimensional model. This process is much like a medical CT scan. The computer measures not only the external dimensions, but also analyzes the sweep, shape, and various features that directly impact the log's overall value. Leveraging this massive data set, the software determines the optimal cutting pattern for each individual log, maximizing product yield while minimizing material waste. Two, sawing and cutting. The log is then automatically rotated into position, aligned according to the calculated orientation, and fed sequentially through the sawing, ripping, and edging processes. A key highlight of Möhringer's technology is its seamless integration of multiple processing steps into a single system. Rather than routing wood through separate machines, the entire workflow, from positioning and parallel cutting to edging, runs continuously on a unified line. This not only shortens cycle times, but also significantly reduces cumulative errors caused by transferring material between machines. By combining precision engineering, high-speed servo-controlled systems, and optimized cutting path algorithms, the entire production line maintains an error margin below 0.1%. More importantly, each log is tailored to its unique characteristics, delivering consistent quality and virtually perfect repeatability throughout the entire manufacturing process. This embodies the core philosophy of German engineering. It's not just about producing fast, but being accurate down to the millimeter. In the final stage, the boards are fed into the end trimming system, where high-speed circular saw blades trim both ends precisely at the locations predetermined by the laser scanner. Immediately following, an automated sorting system uses mechanical arms and pneumatic actuators to route each board to its designated quality grade in fractions of a second. At the same time, every product is labeled with an identification code containing comprehensive data on its raw materials, production history, and technical specifications. Thanks to this data management system, every single board can be traced throughout its entire lifespan. This is not only a hallmark of modern manufacturing, but also the foundation for a more transparent, efficient, and sustainable timber industry. And so, we've reached the end of a long journey. From the snow-covered forests of North America, where a single tree begins its path, to state-of-the-art facilities in the US and Germany, we've witnessed how human ingenuity systematically transforms a natural resource into valuable products that serve our daily lives. Yet, the most memorable takeaway from this journey isn't the giant machinery, the automated assembly lines, or the robots working around the clock. What truly drives the modern timber industry is knowledge, the power to blend science, engineering, and experience to maximize the value of every single log while reducing waste to virtually zero. From Vaagen Brothers with their philosophy of utilizing every part of the tree to Magnolia and its nearly closed-loop manufacturing ecosystem, Boise Cascade transforming wood into smart engineered materials, and Möhringer, where every cut is calculated down to the exact millimeter, they all share one common thread. The greatest value comes not from harvesting more, but from using smarter. Perhaps that is the greatest lesson the modern woodworking industry has to offer. When we respect nature, apply technology wisely, and continuously innovate, a tree becomes far more than just boards or beams. It becomes homes, schools, hospitals, and countless structures that shape the lives of millions. And through this, we realize that the future of the timber industry won't be defined by how vast the forests are, but by human intellect. How we preserve, utilize, and create greater value from what nature has provided. Thank you for joining RaWMachines on this journey through the modern timber industry. If you love large-scale manufacturing, impressive machinery, and want to keep following the journey of natural raw materials into finished products, don't forget to subscribe so you don't miss our upcoming episodes. See you in our next exploration, where we'll continue to unlock the door to the world's most incredible engineering processes.